Hello, welcome back to the Aquarius Samples introductory video series. I'm Alistair Foreman and I'm here today again with Max Buitendijk. He's the product manager for Aquarius Samples. We'd like to continue showcasing some of the features of Aquarius Samples and how it can help you solve some of the common use cases that you may be facing. Today we're going to look at some examples around road salt as a simple example and related chloride levels. There's a whole bunch of information in here that we're going to explore. Max, would you like to walk us through?
Sure, thanks Alistair. I'll bring that right up. So again, I'm going to start from the initial workflow within Aquarius Samples. I'm going to navigate to observations. And here now I'm looking at all my data. I want to get to the chloride data we're looking at real quick. And in case you watched the last video, I'm going to be using the same location. So I'm just going to use this bookmark I've saved the last time to bring this filter up I saved for the last example. So now it already jumped to some locations that I know I'm going to be using. It jumped to the sample medium. Basically any filter you want you can preserve as a bookmark. So that's really going to speed things up. So we're looking at some chloride data. So I'm just going to bring this up here. And now we see we got about 60 results for this. And in order to get a bit of a feel for how that data set looks like, I'm just going to bring it up as a chart again. So I can do the classic XY chart, and I can also use the built-in box plot. And both of those actually will give me a real quick visual feel for how this data set looks like. This one's almost even a bit of a statistical distribution of how those different data sets compare. And it's pretty obvious within both of those data sets and charts that there is a bit of an outlier already, which we can see. By the way, within both of those filters, I could also use the date filter to further narrow down the data set and look into specific seasonal aspects or a specific time frame we're looking for. But for this example, we're pretty good at where we are.
Max, I just want to emphasize that one point that you just made. This chart we're looking at is live, right? It's not a static image.
Exactly. To me, it's pretty much like a visual representation of this filter, whatever data set I've filtered up to right here. This is what the charts are going to show me. So if I were to change these filters, the charts would just adopt to and display whatever I'm looking at right now. And you might be wondering, why is that so important? So imagine if your tool doesn't support that. You can also get to looking at what the outlier is from any sort of chart. But then how do you drill into it? How do you find out which data point that is? So you might have to go back and look at the source data, which might be in a different file. You have to manually match the timestamps to find out that value in question. So if your tool doesn't support that and doesn't do that for you, well, yeah, it's definitely a reason to grab a new cup of coffee and ask that new intern to come over and look at a really interesting science problem we have right there. But so in samples, you don't have to do that. The additional metadata, where that data is coming from, is right there available. So all I have to do is, first of all, I could just hover over points in the diagram. It's going to show that to me. And I can also just click them. And then it's going to bring up all the related necessary metadata and additional information I have about this point right here, such as when was that sample taken, when was it analyzed in the lab. I have information about status and grade, depth, medium, the lab method, sample fraction, detection limit. It's all right there. And also, and most importantly, the additional and related entities, such as the location this was selected at, my visit, my sample, specimen, and shipping containers. So for this example, let's drill into the physical sample bottle, a specimen, as we call it in samples, that in this case was collected at this location, was sent to a specific laboratory. And here's information about field preservatives used, filtration. And down here we can see all the lab requests. This is what I actually wanted the lab to analyze this specimen for. In this case, we can see here's the request for chloride. A specific method was requested. I can also request a preparation method and define the holding time, which will be later very important to calculate if this result was actually analyzed in time. We'll get back to that later. So right up here within this specimen, I can see more links. We call those the breadcrumbs, and they actually allow me to navigate to other related entities within the system. In this case, let's move one step up and let's look at the sample this specimen was split off. So here I can see information, again, very important about the field part, such as what is my sampling ID, which might match to my sampling plan, the type of sample, collection methods, depth, and here I can see all the individual physical specimens, the containers, that were split off from this one sample. And here you can see the different bottles with different analysis types and the individual results that are right there.
I think it's important to emphasize this point as well, Max, and I'll just take a second to do it. One of the issues that we get from customers often is that in the cases where they deal with multiple labs, they often have a hard time tracking in one system where different things are. And as far as I understand, these bottles could all be targeted at different labs. Is that right?
Exactly. So we separated two concepts of tracking your fieldwork, which data is one sample, what belongs together, and the individual containers that could be sent to different laboratories for analysis. They might have different preservatives, different filtration. So those two things are combined in one. And please pay attention to this little orange flag right here. In this case, it's telling me that one lab instruction is still requested, meaning I'm actually missing this result. I haven't received, in this case, my result for E. coli right there. So it's a great tool to track if I've received all the results I'm waiting for and if I have all the data that I need.
That's really great. Can we go back and look at that outlier? What's going on?
Right. So this is the sample that this result of that outlier is coming from. And we can see here some comments from my field crew that there's some pictures attached, and there might be something going on, maybe a puff of snow. So let's go to the visit. The visit holds more important data about how this data was collected. So I'm just going to navigate to the attachments right there, and I'm going to download this picture. Just notice it's just going to download it from my browser right there. I'm just going to open it, and yeah, there we go. Maybe it's just some big old pile of dirty road snow with lots of salt in it that might be melting away just upstream of my sampling location, which might be the reason why we have elevated chloride results. And of course, this is a simple example, but it really is a good explanation of how the data can unfold and really start telling a story as you drill into the related metadata from individual data points and how the system's going to help you how to make that easy.
So the key point here, I think, is that you really don't have to spend too much time to kind of get all this information. You don't have to search around different systems and so on. It's all right there. I know we hear from customers all the time that they are doing this kind of analysis today, but it's pretty hard because they've got to fish around for all the data. So for example, they sometimes have to go back and look at field notes, or they have one person whose handwriting is hard to read, and so on. So the additional data in samples that we've seen are all good examples of what we're trying to accomplish here at Aquatic Informatics, and that's to build modern and simple, intuitive systems that allow our users to instantly be productive and successful. Okay, so thanks, Max. We've looked at existing data about this chloride outlier, for example. What about new data and data validation?
Good point. That's a very important part. And just a heads up, the import new data scenario we'll cover a little bit later. It'll be coming up in another video. But I'll show you how to validate data that you already have. And I'm going to go back to my observations, and I'm going to go look at this chloride data set that we already have been using within this example, since I know there's some good validation rules in there. I'm just going to use this header here to sort the high results up top. I can click any of those and filter just as you're used to doing in other software. And now we can see, by the way, here's this outlier we've already been looking into. Here's some icons, some flags and validation rules that the system is trying to help me pointing out the results that actually need my attention. In this case, somebody might be monitoring a National Aquatic Life criteria for chloride, and we can see this example is exceeding that. Here's different validation rules and flags. This example, for instance, the lab has issued a quality flag, which I can see right there highlighted. In this case, we can see another flag where the system indicates that the sample fraction is not valid with the filtration of my specimen in the field. So I have a total value being produced or being shown for a filtered specimen, which would be an indicator of probably bad data. Another example would be the system flagging QC results, specifically telling me what type of QC sample this is. In this case, it's a replicate. Important for me to know if I might want to use this data in this query or not. And here's another example that we referenced before. The holding time for this result is exceeded, so might be another reason for me to change the grade or maybe consider this result or not.
So hold on a sec there, Max. I think just briefly before we looked at these flags, a non-detect showed up. And I know that those are special in samples. Can you tell us about non-detects?
Right, let's bring that back. I think it was right here. Yep, there we go. So we can see this non-detect here shows less than 0.5. And let's just select it to bring up some more information. So you can see the actual result, it's not less than 0.5, it's actually non-detect, that's what it is. But the system knows that here, it knows my detection limit, so it will actually automatically do that for you. So you don't have to manually fiddle with your data and change your results and to remove or add disqualifiers. The system has that built in. And furthermore, if we look at the chart that we already looked at before, we can see down here, it's a very small value, but the tooltip will help. So it's got a built-in configuration that allows you to use a certain percentage of your detection limit to use that within the charts. So without any manual interaction, you can just plot your non-detects, or you could export that or whatever, and use a specific share of the detection limit to show. And that's really simplifies life with regards to non-detect. You don't have to ever change your data, and you will never lose the information that your non-detect in fact is a non-detect. You will be able to tell historical data, and you don't have to ever change it. In this case, it's 50% what that organization is interested in using for detection limits. But that could be any other setting depending on what your organization needs to do.
Oh, that's really interesting, Max. Thanks. So the other thing that I noticed on the previous screen was this reference to a standard. Can you describe how those work?
Standards, right. Yeah, that's another powerful set of metadata that's configurable within AQUARIUS samples. So I'm just going to open the settings section right here, where we'll have things like units, observed properties, methods, which we won't cover into more detail in this video, but I'm just going to go to standards right here. And you can see it has already filtered to the chloride standard we've already been looking at. I'm just going to remove that and show there's a whole bunch of different standards you can load. Those can apply to a specific set of locations, specific time frames, and each standard can have specific rules about individual observed properties or parameters that you might be interested in. But we'll leave it as an overview for this demonstration.
Great, thanks, Max. So that concludes our second video in the series of AQUARIUS samples. We'll be back again with another video. Thanks for watching. See you then.
See you later.